Hello, I'm Ray, the Ray in the Ray Code. In this video, I'll be covering the prototype design pattern and I'll be using C++. I have put timestamps in the margin so you may navigate to the section you desire most. My favorite is SWOT analysis. I have used other programming languages to cover this design pattern, and I have used this programming language across all the other design patterns that were mentioned by the Game 4. Please like this video, leave a comment, and subscribe. You can find me on all the social media platforms. Please search them out. Become the Ray Code groupie. Please share this video with others. The prototype pattern is about creating a new instance of an object by copying an existing instance which serves as a prototype. Instead of constructing a new object from scratch, an object that is already initialized with certain states is cloned to produce a duplicate. This pattern involves two main actors. One, prototype. This is an interface or abstract class that declares the cloning operation. 2. Concrete prototype. This is a concrete implementation of the prototype interface and implements the cloning operation. Typically, it might use a copy constructor, cloning method, or other mechanism to achieve this. Key idea. You start with a prototype object. You clone it to make new objects. Each clone can be modified if needed. Basic structure. Prototype base class declares clone. Concrete prototype implements clone. Client uses clone instead of new. When to use it? When object creation is costly, we need many similar objects. We want to avoid complex structure. Reason studying the prototype pattern is beneficial for a C++ developer. Efficient object cloning avoids the cost of repeatedly instantiating complex objects by cloning existing ones, boosting performance in C++ applications. Runtime flexibility enables object creation at runtime without binding code to specific classes, ideal for C++ programs requiring dynamic behavior. Simplified object creation reduces complexity when instantiating objects with many default settings by copying prototypes instead of recreating them manually. Decouples object creation, eliminates need for new in client code, keeping creation logic separate, making C++ systems more maintainable. Supports polymorphic cloning, leverages virtual functions in C++ to clone objects based on their actual type, preserving runtime behavior across subclasses. Here is a UML diagram for the prototype pattern, a creational pattern for the C++ student. Prototype declares a virtual clone method that returns a pointer to a copied object. Provides a common interface so all derived classes can be cloned polymorphically. Enables object creation without specifying the exact concrete class. Acts as a base class, ensuring consistent cloning behavior across all prototypes. Concrete prototype implements the clone method to return a copy of itself using its copy constructor or custom logic. Ensures the correct concrete type is preserved when cloning, no slicing. Handles deep or shallow copying dependent on internal resource ownership, e.g. pointers. Encapsulates details of object duplication, including memory allocation. Client creates new objects by calling clone on the prototype instance. Interacts with the prototype interface, not the concrete classes. Avoids direct instantiation using new concrete class, reducing coupling. Relies on polymorphism to generate objects dynamically at runtime. I hope you're enjoying this video. Be sure to like and comment. If you have an improvement I could use, just let me know. Hello, I'm Ray, the Ray in the Ray Code. In this video, we will continue our study of the design patterns, in particular, the creational patterns for this series. In this video, we'll cover the prototype design pattern. The prototype pattern is a creational pattern. Its job is to create new objects by cloning existing objects instead of building them from scratch with new and direct construct logic every time. We start with a class I call prototype. We will create the .h file. We include string in the header because we will use it to write to the console in our demo. We want to allow for writing string instead of std : string. The prototype class declares the abstract base class named prototype, exactly like the name used in the UML of the book written by the Game 4. This constructor initializes the prototype with a name. We have a particular variable named. I will use name so that each prototype object can carry identifying data. The virtual deconstructor ensures correct cleanup through a base class pointer. A pure virtual clone function that derives classes must be implemented. Now let's create a class called Concrete Prototype 1. Teaser, there will be a Concrete Prototype 2, just watch. This file declares the first Concrete Prototype class. We include Prototype H at the top, the base Prototype class, because this class inherits from it. We also include string support for string data members. We extend this class with prototype. This declares Concrete Prototype 1 as a subclass of prototype. We use an integer variable to be a unique identifier to this prototype object. Next, we have a Concrete Prototype 1, which receives the parameters name and int ID. We start the public section for accessible class members, declare the constructor for setting name and ID. We declare the constructor for setting name and ID and override the base class clone function. Override the display function. Now let's create the CPP side of this class object. On the CPP side, we include the matching Concrete Prototype 1 at the top, so the compiler knows this is a class definition. We also include IOStream for output support. We fix the prefix for standard out, so the compiler just writes standard out, allowing us to drop the prefix, and we drop the prefix to the inline also. We construct the object by passing the name to the base class and store ID locally. We define the clone function that copies this object, create and return a new object using the copy constructor. We define the function that prints the object's current state and displays the class name and member values. You knew it was coming. Now we create Concrete Prototype 2. This file declares a second Concrete Prototype class. At the top of the file, we include the first Concrete Prototype we created. Also, the IOStream for standard output. Also, we want to allow to have cout and inline without the prefix. We have the class structure for Concrete Prototype 2. We extend this class with the prototype. We have a private value which will store a numeric value to distinguish this prototype from the first one. Next, we have the public section where we have a Concrete Prototype 2 taking the name of and a double value. We override the base clone class operation and we override the display operation. Next, we need to create the CPP side of this class. We include the .h file and the IOStream at the top. Like Concrete Prototype 1, we also extend this class with the prototype. This makes Concrete Prototype 2 as another subclass of prototype. Here is the end of the line. Next, we define the clone method for this class and return a new copy of the current project. We print the class type and stored data. Now for our demo, we go to the main CPP. At the top, we include both Concrete Prototype 1 and Concrete Prototype 2. Allow use of cout and inline without prefix. Inside our main function, we print a header for our project that reads Prototype Design Pattern Demo in C++, and we print a line separator. We create the first prototype object through a baseline pointer, and then we create the second prototype object through a class baseline pointer. The values of the first original 101, and for the second one, original 99.95. And we show original 1 an original 2, which is not original, and we return 0. Let's compile and run. We get original objects, concrete prototype 1, name original 1, ID 101. Concrete prototype 2, name original 2, ID 999.95. My name is Ray, always code with a smile. SWOT analysis of the design pattern prototype, a creational design pattern for the C++ student. Strengths. Improve performance. Cloning existing objects is faster than constructing new ones from scratch in performance-sensitive C++ systems. Reduces code duplication, avoids repeating initialization logic by reusing pre-configured prototypes throughout the C++ application, enhances accessibility. New object types can be introduced by simply registering new prototypes without modifying existing logic. Weakness. Deep copy complexity. Implementing deep copies in C++ can be error-prone, especially when objects contain pointers or dynamic memory. Requires clone contracts. Every class must implement a virtual clone method, which can add overhead and complexity to the class hierarchy. Difficulty debugging. Debugging clone objects may be harder if the cloning process doesn't correctly replicate internal state or reference. Opportunities. Game development use. Frequently used to duplicate entities like NPCs or bullets in C++ game engines without performance degradation. Prototype registries. Useful for implementing registries that manage and spawn new object types based on registered prototypes. Configurable prototypes allows developers to pre-configure prototype objects for reuse, improving code reuse in plugin-based or modular C++ apps. Threats. Incorrect cloning logic. A mistake in the clone implementation can silently propagate bugs, especially in multi-leveled inheritance trees. Memory management risk. Improper handling of dynamic allocated memory during cloning may lead to leaks or undefined behavior in C++. Misuse in simple scenarios. Applying the pattern in trivial use cases as unnecessary abstraction and might confuse newer C++ developers. Well, that was my video. Please give this video a like. I worked hard to create it. Leave a comment, and if you find me on the social media platforms, leave a comment there. Tell a friend the Ray Code is awesome.